What happens when a passion for precision meets a mission to help others bring their ideas to life? Welcome to Industry Ignited, the show where we unpack how real innovators turn ideas into systems that actually work. I'm your host, Dr. Leeanne Aguilar. Today, I'm joined by T'Ray Rutledge, PE CEO of Circle R Engineering and a licensed mechanical engineer. He designs across hydraulics, pneumatics, electrics, conveyors, and material handling, serving both companies and individual inventors who want to get concepts off the ground. T-Ray, welcome to the show.
I'm so happy to be here. I'm looking forward to having a great discussion with you today.
So, you weren't raised around mechanical systems. Then the Air Force happened. What clicked for you on the flight line that set your direction toward mechanical engineering?
So you're right. I was raised up on a ranch up in North Arkansas, and I joined the Air Force and I became what's called an aerospace maintainer. I was basically a mechanic for aircraft. Uh, my job was to go through and inspect the mechanical systems that were on the airplane, looking for issues and stuff like that. And when you start dealing with that kind of stuff, you're getting familiar with how the mechanical system is supposed to function, but it kind of sparked a curiosity into me of, well, why is this working? What makes this actually work? Uh, so while I didn't have the mathematical or the scientific background at the time to figure it out, I could figure out, okay, well, you have a reservoir that goes to that's going through a pump that goes out to our wings that's going to control our wings and our tails, and seeing up at the top about how many electronic controls go into it and the safety that we really put into the aircraft and maintenance. So really dealing with those mechanical systems really kind of sparked me towards a mechanical background and a mechanical curiosity.
All right. So you just saw how the systems were working together, and that sparked your curiosity and just I guess, the engineering part of it and wanting to learn
A-
more about, yeah, how it all worked together and what made it work.
Absolutely. I mean, when you see a gigantic aircraft like a C-130 take off into the skies, if it doesn't make you at least a little bit curious about how that's happening.
How did your time as a C-130 crew chief shape the way you approach reliability, safety, and inspection today?
So I really think, as far as all that goes, it really kind of number one, it gave me a good idea of how to properly make something that's safe. So, I'm always looking at like, okay, well, what did I see in the past, especially in my Air Force background, that I feel like increased safety? They didn't have exposed gearing. They had pressure dump valves on all their hydraulics to make sure that if you were performing maintenance on this one section of the plane, that I could remove pressure from the one section of the plane without affecting the rest of it. So it really kind of goes into how can I best design something that's going to be easy to work on and has as many safety precautions. I don't have exposed moving parts, I don't have exposed electronics, and trying to make it as safe as I can in a work environment, or if it's going out into the public, make sure that the public is not going to accidentally get hurt with what we're doing.
Right. Yeah. So especially on aircraft, safety is a huge part of what you're dealing with when it comes to the mechanics and just understanding the implications there. And again, how the different controls or the different parts of the plane impact safety.
Yes, ma'am. And like I said, it's really seeing all of the safety precautions to go in because sometimes you stack safety precautions. You can see where somebody could accidentally do something, and so you're going to add maybe two or three layers of safety to prevent that from happening. And like you said, when you're up in the air, you have an aircraft up in the air, you put as many safety barriers as you can. We try to make, I've heard them call it in the aerospace industry, they call it the Swiss cheese model of a lot of things are going to have to go wrong in just the worst way for something to actually happen. So you
A lot of
try to
layers of,
really limit that.
yeah,
Yes.
backup systems. There you go.
Yes, ma'am. Absolutely.
Yeah, that makes sense. That makes me feel more confident, I guess, flying in an airplane, right?
Yes, ma'am.
Walk us through the transition in internships, Arkansas State, early design roles. What were the pivotal projects that built your confidence?
So my first internship was at a steel company called Nucor, and I really started off with really kind of basic level projects. I was doing a lot of stress analysis. Uh, I think my first big, somewhat project was just really a platform that was going to be raised and lowered. So I did a lot of stress analysis, really learned about what the safety factors needed to be into that. My next internship, I went to a greeting card company and learned a lot about efficiency. So I worked a lot with where can we increase storage, material handling, saving time to get from one place to another. But it was really my last internship that I think I really got heavy into the design aspect, designing a few mechanical systems and really getting into designing systems that need to be safe and easy to maintain going into the future because it was another steel company, and so they need everything that they do to be highly efficient, and they need as little downtime as possible. And these are usually components that are going to be in a pretty high stress, high load environment. So it was really a lot of I kind of graduated up until I graduated, and then that really even took it to a whole nother level once you graduate and you get to your first company.
Yeah. Right, I can see that. So it's just the stacking of knowledge and the different experiences, throughout the different internships that ultimately will guide you oftentimes into where you end up. Now, tell me about, I know you earned your PE license as well, so now you're a professional engineer. What did that milestone change about your mindset, your practice, and the kinds of problems you take on?
I think it had a pretty significant impact on me, actually. You know, I graduated from Arkansas State and I started working at a utility company making utility equipment. And I was always trying to see what was up and coming, what was new. But once I started studying for the professional engineering exam, it really kind of opened me up to not just, okay, well, what else is happening in the industry? What is everybody doing to improve the industries that they're in? But also my mindset whenever I started looking at a problem, whenever somebody comes up to me with a design, I'm no longer just thinking of, well, what does everybody else have that I can kind of incorporate into what I'm doing? I take a look at it a lot of times now, going, okay, well, these are some good options, but what can I do? How can I take something that somebody else is doing and improve it for my customer? So it's been a lot more of not being so single-minded, not trying to think of the right way to say that.
Right. So just opened up your mind. It expanded the possibilities when it came to how you look at problems and possibilities for solving problems, perhaps.
Yes, and I think it also makes me keep more current on calculations that I may not be using on a day-to-day basis. I have to do recurring training every year, and so I try to make sure that I strengthen up my weak points as an engineer, or the best way to say it is things that I may not be using on a day-to-day basis that I think could help my customers or companies with what they're doing.
Right. So it represences you to like aspects of engineering that you're not always using and keeps those fresh in your mind. So they're, yeah, available. So you specialize in powered systems, hydraulic, pneumatic, and electric. When you first scope a problem, how do you decide what form of power makes the most sense?
Most of the time, that's going to be driven by the customer's needs. So they may come to me and say, I have an air compressor and I want to power it with air, or they might only have 120 volts available and we might have to deal with that. But a lot of times, I think it's going to really design on what the customer is trying to get out of it. Are we trying to move a large load? Because if we're trying to do that, then hydraulics and electronics might be the best scenario. If it's a light load, but they want to move it fast, pneumatics work great for that. Air powered systems, they're usually a low pressure, so we can move lighter loads fairly quickly. So a lot of clamping scenarios. Uh, rotational systems, most of the time we're probably going with a motor drive system, but there's always exceptions to these rules. So you can always take a motor and put it on a ball screw if you need to, but there's a ton of different scenarios that can go into that. But I would say the biggest three is going to be power or load that you're trying to move, what's available, and the speed that you're trying to move that item.
Okay. Yeah, good pointers there, and also, I guess, yeah, the client's need and the environment and the application itself, so a lot of factors that you consider when making that decision. You emphasize maintenance-friendly design. What are your go-to tactics for reducing downtime and making service access painless?
So as somebody who worked in aerospace maintenance, so I was dealing with maintenance, I know the headaches that can come with trying to keep a system up and running, especially in a timely manner. So the number one thing that I try to do is I try to consolidate my maintenance points. So if I'm designing a hydraulic system, I'm going to try to put as many of my valves and as many of my pumps and everything all in one location as much as I can. And that way they don't have to search for where this system is going, where this system needs to be checked at. Another thing that I do is I try to look at components that may have a longer life cycle between maintenance points. So stuff like bearings, I might try to go with a little bit of a heavier duty bearing that is not going to need to be greased as often, or maybe has a very longer life cycle than another bearing that might work in a similar scenario. Uh, and then the other thing that I try to do, if applicable, is I try to make a removable system a quick change system so that they can pull maybe a whole entire unit out, put another unit in while they pull the other system out and perform maintenance on it. And it's all about trying to minimize the amount of time that the line has to go down from the time that you start maintenance till the time that they're done. So those are kind of the biggest deals.
Right, keeping things efficient and easy to maintain and to work on too. I think it's difficult when, right, a system or something is buried and you have to go, yeah, pull out
Yeah,
everything else,
yeah,
gut things before you can actually get to what you're trying to work on, and that's,
absolutely.
yeah, it doesn't make sense,
Yeah,
and,
yeah. So you don't want to put your maintenance points in an incredibly busy area. You want to make it as open and as easy to get to as possible.
as possible, right, and I like the removable components like you were mentioning as well, so that keeps it, um, easy to work on as well.
Yes,
Power
ma'am.
efficiency also matters. How do you size drives, motors, and orchestrate systems to avoid wasted power without sacrificing performance?
So really, as far as all that goes, we have to really look at what's the range that we're going to work in. So a lot of times where the engineering with this comes in is I might look at an electrical drive system that's needing a certain output torque and a certain output speed. And from there, I can kind of get a rough power requirement. So if you put in a larger drive, what can happen sometimes is you might put more power into the system than it can actually handle. It can cause mechanical failures down the road, but it can also take more power consumption to do the same job that we're trying to do with a smaller motor. So this will also save companies a ton of money in the long run because when you're working with higher for one or two motors or something like that, you're probably not seeing a gigantic increase in electrical efficiency or savings due to electrical efficiency. But when you're dealing with some of the companies like I deal with, where they have thousands of motors on site, just saving a half horsepower here and there can be a huge benefit to their company.
It adds up, right?
It,
It all adds
it
up over
does,
time,
absolutely.
right? Yeah, especially if they're running around the clock and,
Yes. And a lot of companies
days
that are
at
that
a
big, they run 2 to 3 shifts, so they're running almost all the time.
yeah, yeah, so it definitely adds up.
Yes,
You've
ma'am.
also worked in steel, woodworking, utilities, sanitation, and agriculture. What design principles have proven truly cross-industry?
So, surprisingly enough, there's a ton of overlap as far as design principles. It's really the small nuances as a designer that I really have to watch out for. So whenever I'm dealing with, say, in the agriculture industry, I'm dealing with a mechanical equipment that's about to be used around cattle, for example. Well, I have to really make sure that my top end is not going to hurt the animal. So I don't need to put more torque into something that an animal is going to get trapped in. And you also have to think of it no longer from, well, what's a person going to do in this system? How is a person going to interact with this system? Animals and people act completely different. As far as like woodworking sawmills, a lot of the stuff and I think this was something I really had to learn with their system is the load that you're trying to move does not always designate the size of the equipment that you're actually making. So a lot of the chains and stuff that we used in designing stuff for these sawmills are have a load capacity way more than what they're hauling, but the chain attachments that they require a certain size of chain to keep the log balanced on the chain. So it's really kind of getting into the nuances and figuring out the extra safety features that each one needs. So like I said, what can we do to protect the animals? We're creating sawdust. How do we keep that from getting up into the air? Uh, you know, at steel industries, when you're pouring coolant into a system, you got to have a good place for the coolant to go to. So it's really, as far as the design goes, it's really similar. You just got to look for the small differences between each industry.
Yeah, so really considering what's in the environment and whether what other elements you're working with. That's interesting and very important, I think, and,
Yes,
like you
ma'am.
said, it doesn't I mean, while systems are similar, those different variables in the environment are gonna have a big impact on how you put it all together.
And I think that's part of the joy that I get out of this job is, especially whenever I get to jump into an industry I haven't been a big part of yet, is figuring out what they're looking for specifically in what they're looking for. Uh, I've been working with an agriculture company for a few years now, and it's been a completely different beast than working in the utility industry, to where you're working with people and working around kind of in the mindset of, well, what's a person going to do? How is a person going to react to this system? How can I make this easier on the person? A lot of times working with animal related stuff, we're also looking for, if the worst case scenario happened, how do we get the animal out of the system?
Mhm. Right, because like you said, animals behave differently than people do, so you've got to consider the reaction and the behavior of the animal when, yeah, designing the system. So, in
Yes,
order to
ma'am.
protect the animal and the system, I would think as well.
Absolutely. Absolutely. We
Yeah,
want happy animals.
yeah. Many inventors know the outcome they want, but not the path. What does your napkin sketch to prototype roadmap look like?
So it always starts off with a consultation. So I'm going to sit down with the customer and we're going to talk about what are they wanting? What's their inputs? What's their outputs? What's their parameters? What's the scope of this project? After the initial consultation, I'll go through and usually start doing some analytics and calculations. This is usually just trying to figure out, okay, well, what's the best path forward? And then I'll start generating a rough concept to present to the customer. After the concept is generated, usually me and the customer get back together and I'm going to present them, okay, here's maybe one option or here's a couple options, or let them know what the findings are, because we want to make sure that our client is involved in the process from start to finish. This is their project. I'm just helping you get it to where it needs to be. Once we kind of get past the concept stage, they see a concept, they like the concept, we'll start detailing it out. We'll start doing more advanced analytics on it, seeing what all goes into it. And then before we start putting the final touches, which we're going to be involved with the customer the entire time, but usually we'll have one more meeting with the customer to let them know everything that we're looking at. What's the cost? Uh, what all do we need? Do we need to send this off to machine shops? Do we need to heat treat some of these elements? Uh, Is there a thermal efficiency issue that we're running into here? Stuff like that. And then once they're finalized with that, we'll start to button up the project. We'll make all the prints. And if they want us to, we'll start the prototyping systems for them. So we'll help them build the prototype, test it. And then once we're completely happy with it, we'll even help them go all the way to the product itself and getting that out to the market.
Yeah, so it's really a step-by-step process, and the
Yes, ma'am.
client's very involved along the way. Um, what do you use for your creating models? I mean, is it all just, CAD or 3D design? Do you ever do, like, 3D printing or any of that to demonstrate your
So I,
model?
so I don't do a whole lot of 3D printing. I do have some companies that I can use for those scenarios that we kind of work together with, but I do use mainly 3D CAD, and it works out really good for a lot of the designs that I do because I can do a vast arrangement of analysis on this. I can do a motion analysis, I can do a stress analysis. I can usually kind of see as we're going through the motion what power is required at that point through the motion. And so those are kind of things that we use the 3D software for. And it also provides a great visual aid to our client. Sometimes we're dealing with highly technical clients and they don't even need the visual aids. But
Yeah,
sometimes you're working with the general public and you're trying to explain a system to them that even as an engineer talking to another engineer might sometimes be a little bit hard to describe, but seeing it in a 3D version really a lot of times helps the clients see where the project is going.
right. Yeah, it makes it more real, I think, and right, even if you're knowledgeable about the technology and the systems and how engineering works, I think oftentimes just seeing it and then it gives you the opportunity to, ask more questions and solve or troubleshoot other areas before actually producing the prototype. Where do most
And
first-time product builders stumble? Requirements, testing, manufacturability, or compliance? And how do you steer them around those traps?
so I would actually say I think the biggest hurdle that they start with is usually right out of the gate. You've had this idea in your head and you want to start making it a real result, but sometimes it can be a little bit intimidating to start a whole new venture, to start putting something out there. You might have this idea, you might have a general idea of the way it's supposed to go, but you're some people get a little bit nervous just to get it started. So we try to really help them with that. That's why we offer free consultation at the very beginning because you can come up here, we can discuss your idea, we can talk about it, and usually a lot of times that'll kind of get them a little more excited about moving forward with the project. I'd say probably the second biggest hurdle that they're going to have to get through is sometimes to see the process to get there. Like we said a second ago, we're just talking about the main points through the project design, but that's not even talking about hitting all the many points, I guess, in between. So, you're talking about, okay, if we're talking about a hydraulic system, now we're talking about pumps, filters, valves, directional valves, relief valves, flow control valves. You're gonna have a tank that it has to go to, and stuff like that. And so sometimes that can be another hurdle for them. Maybe they've got the idea, maybe they've sketched it out on a napkin, maybe it's looking great. And so, the next biggest hurdle is, well, I know what I want this to do, but I have no idea how big it actually needs to be. And I would say probably the final hurdle that people get through is going to be actually right there, kind of towards the end of the project. Um, I'm dealing with a person right now, and he's come up with a great idea, and I'm helping him get it there. But he's got this concept, he's got it drawn out, he's got it figured out about what all he's pretty sure that he needs, but he didn't know how to size it to finish the project off. And so we've been working with him on sizing the electronic components, the electrical schematic that actually goes into it, and what actual components that he needs to finish this project. So I'd say that it's kind of mostly at the beginning, every once in a while at the end, but usually once we kind of get them get the balls rolling, usually it's a pretty fast process.
Yeah. Well, and that kind of leads into my next question, which is when you inherit a partially developed concept, how do you evaluate whether to refine, re architect, or restart?
So I would say restarting is a very rare occurrence. Almost never do we have a fully restart. Now, we might have to take something that the client had in their mind and we might have to shift it in a slightly different direction. But usually a lot of times what happens with that is more with the individual levels because they're coming up to us with a design and maybe they have a small motor put into a system. But as we discuss it, well, it's going to take a little bit more power than what you were thinking. So we have to package this up a little bit differently. We can't do an inline drive. We might have to do a worm gear drive, or they might have a ball screw system put into something. And it turns out that it's going to be in a really contaminated environment that ball screws don't do well in. And so maybe we need to look at doing something maybe a little bit more pneumatic or do a 4-bar linkage system or something like that to get the motion that they're wanting out of the system. But that's usually stuff that we can usually work with pretty quick. Usually we can solve that pretty fast and early on. So even if it is a sort of a restart, we're usually not very deep into the project when that happens.
Right. And most most projects are salvageable to some extent, you're saying, and you take what you're given and try to work with it as much as possible instead of just starting from scratch. But really
Yes, ma'am. And
looking at
wait,
what's that?
yes, ma'am. Yes, ma'am. We really
Yeah.
we want to make the customers' ideas come to life. We're not looking to make changes to what they're giving us. We're just looking to make it as efficient and as functional as possible.
Yeah, just really streamline the process.
Yes, ma'am.
What's a favorite example where you simplified a multi-process or mobile system, and what performance gains did that unlock?
Yeah, I got a couple that always kind of stick into my mind. Uh, One was converting a diesel powered system to a uh, electric over hydraulic system. It was in a very uh, busy type of industry to where communication is key. They're dealing with very high loads, and so when you have a diesel powered system, you have this say 173 horsepower engine running in the background, and you're having to wear dual hearing protection around it because it's so loud. And now you're trying to communicate with people over radio that they can't even see what you're saying. So you have to really be very vocal with that. When we switched it over to the battery driven system, we took the noise completely out of it. It was now a completely silent system that people could talk like you and me are talking now to each other and have better communication. But the other one I worked on was basically combining three machines for a sawmill together. And what it allowed us to do when we started that project was number one, it got rid of three machines and combined them into one. And it was a longer machine, but it took the material handling as it came out of one machine. You you move it all onto a pallet, you take it to another machine, you load it into that one, uh, then you take it to another machine. After it gets out of that one, you do that. So we took all of that extra legwork out of it. It was you put it into one side and it goes through the whole entire system. It comes out a finished product on the other side. But at the same time, it also had a way to deal with the waste that comes out of creating these products. So not only did it actually save the time of them having to transport this from place to place and reset up every time, but it also gave them a better way to get rid of the waste that's created during that process.
Okay. So you basically re-engineered the system not only to become more efficient and streamlined, but it also took care of another problem, which was the waste disposal.
Yes, ma'am.
Yeah, that's awesome. Now you're working toward becoming a registered patent agent. Tell me about that. Like, where do you see the biggest needs, and how will that capability expand Circle R's impact?
So we deal a lot with individuals that are trying to get their designs up and off the ground. And what really hoping we can do with this is kind of give them a one-stop shop. We can come in, we can do the design work for you, we can file the patent, and when we're finished working together, you'll have a product that is fully patented, ready to go to market. This will also actually save them a little bit of time that's usually not wasted time, but it's usually a required time when you start talking to patent agents or patent attorneys, where you're going to have to describe your project in great detail to these patent agents so that they can draft up the patent forms to file for you. So you're having to basically teach these patent agents what you're doing. If you come to us and we do all the design work for you and then we start the patent application for you, we don't have to spend that time during that process because we've been with you the whole entire time. We know what this thing's doing.
Right.
We've worked with you. You're the expert, but we have worked with you enough now that we know what this design is doing.
Yeah. Right. So I mean, you already know how it works. So if you're the patent agent, then you don't have to try to explain it to a third party who may or may not understand the engineering and write the process. So it just simplifies it and makes it easier probably to even get the patent, right? For the
It it
customer.
can, and it's really a lot of patent places are going to charge you by the hour, and so you're talking about probably 4 to 8 hours of time for the initial consultation, the research that they're going to have to look up to make sure that they use the right descriptions of what they're doing. So it really just kind of saves them that time because we've already done all that. You and me, we worked
Yeah.
through the design, we created this. I know it, I know exactly what it's doing.
Right. Oh, that makes a lot of sense. Yeah. Are there a
Yeah.
lot of engineers who are also patent agents?
So you actually have to have a technical degree to become a patent agent. So a lot of patent agents are do have an engineering background, but most of them are actually working for law firms, not
That's what I
engineering
thought.
firms.
Yeah, that's what I
So
thought.
so
Uh,
while they have an engineering background, they're not going to be doing the design work for you most of the time like we will. Like
right.
I said, we're one to help you take your project from, like you said, the napkin to a fully patented product ready to go out to market.
Yeah. So full circle service
Yes,
there.
ma'am.
Agriculture and material handling are booming. What innovations do you expect to see in the next few years?
So I would say, as far as agriculture goes, we have seen so much innovation happen in, I would say, the farming side. So crops, you see all these automated tractors and equipment out there now. I think that there's a lot of stuff coming really soon for these ranchers to help them take care of the animals that we see in agriculture. Not just better processing, but I'm talking about giving the animals better lives and making it so that we have a better way to get through our system. So, when you're working cattle, you know, seeing all the automation that can help you get through your cattle operating systems. And as far as that goes too, what all can we do to help these ranchers, not just with that, but I guess more with storage and communication in their networks. So it's all about, when you're dealing with animals, you want everything to be fast. You don't want to disrupt your animal's life more than you have to. And so I
Right.
think that's the biggest innovations coming there. As far as manufacturing, we're kind of seeing it right now in a lot of ways, but it's automation. We are dealing so much with automation nowadays that uh, like the example I used earlier. We took three machines that you needed a ton of people to work with to get it from a starting point to a finished product. I think you're going to start seeing a lot of more complex machines that are coming out that are going to decrease the handling. And it's not to take away from the number of people that's required to do something, it's to more of eliminate the waste of travel, but also the less times that people actually have to handle the equipment, the safer the process becomes. You know, you don't want people dealing in a process that has moving equipment and them have to be right there on top of it.
Right. Yeah, so it increases safety, and, yeah, I was just thinking that as well, just removing people from parts of the process that might be risky or dangerous and creating a streamlined process that's more efficient at the same time.
Yes, ma'am.
For veterans and young engineers eyeing entrepreneurship, what's the single best habit to develop before taking on client work?
So I'm thinking about this. I've got three that I think actually, I hate to narrow it down to one, but I got three that I think are great habits to have. One I think is kind of the most obvious, which is to be curious. Look at what's going around. What needs to be improved on? How do things work? Whatever industry that you're in, be curious about your industry. The next thing that I would say is discipline. I think you need to have discipline in whatever you're doing. So you need to work hard to make whatever you're doing as good as it can be. You know, it's not all about design work. If you're out there and you're making a product, it's okay. Well, is my product solving all of the customer's needs? Are you providing a service? Are you pro- are you providing enough? Are you providing the service fast enough or in a timely manner enough to satisfy your customer? And I really think the final one, I think this one might be a little bit more uncommon, but I think is to be more selfless. A lot of the great things that happen out there, you see these great things that move industries forward. It's people coming up with ideas that's improving somebody else's work life. Uh, that's something that we really here at Circle R Engineering try to really push is we want to make the customer happy. You may show me a design and I may want to design it a certain way, but if you're the customer and you want it this way, we're absolutely going to do that because we want to make you happy. But I also think as far as all that goes, when you see these great innovations that are pushing forward, like I said, it's going to be mainly by people trying to make other people's lives better.
Right. Yeah. Focusing on the client and their needs, and while you may have your own desires and points of views, it's really about serving the client the best, and so putting yourself aside to listen to the client and understand their needs and working towards meeting their needs, and so, yeah, I like that, yeah, so curiosity, discipline, and being selfless in serving your clients.
Yes,
Well,
ma'am.
T. Ray, thank you for taking this time to look under the hood of how discipline engineering turns into dependable machines and products. Where can listeners connect with you or learn more about Circle R Engineering?
So you can visit us at our website, circlrengineering.com. We're also on Facebook and LinkedIn, and we connect a lot with people. You see our contact information there, and we look forward to trying to help more people innovate to elevate their businesses and lives.
Great. And to everyone tuning in, if today sparked an idea, follow Industry Ignited and share this episode with a builder on your team. Until next time, stay bold, stay curious, and keep igniting industry.